All right. So, welcome everyone to this particular session. So, we are live again with a new session and welcome back to this channel of Pradhan Academy, right? So, today we are again back with a different concept, and in this today's session, we're going to discuss the part of algebra. So, I wish you all the best, and if you are new to this particular channel, I will request you to subscribe to the particular channel, and we will basically need to discuss all the important JEE Mains questions as well as previous year problems, right? So today our goal is basically to discuss about quadratic equations, right? So we started this particular series where we are discussing the JEE Mains previous year questions as well as some of the important topics, right? And in this particular session we are discussing some of the concepts as well as very important chapters as well as the concepts and the question that are basically based on that, right? So we are going to discuss this particular part in a detailed manner, right? So I welcome you all of you. All right. So if you are able to hear my voice, please let me know. Right. So if you have not watched the previous lectures or the previous sessions, I will request all of you to please go to the channel and you will find my live sessions under the live tag, right? So as of these sessions concerned, we have already started discussing the straight lines, we have finished circles, we have completed parabola, we have completed ellipse, we have completed hyperbola, right? So entire chunk of the coordinate geometry is completed, right? So if you haven't watched that particular session till now, I would request all of you to please check the channel, please check the videos under the live tag, and you will definitely get all the required content that you need for your preparation, right? Now these contents are really going to be very beneficial as well as useful for your JEE Mains upcoming paper, right? And not only for JEE Mains, we are also going to come live and we're going to prepare together for the JEE Advanced as well, right? So stay tuned for that, and I would like to see you all of there, right? So I hope you will see the red button over there. Please don't forget to hit the subscribe button and hit the bell icon that is beside the subscribe button so that you don't miss out any upcoming live notifications, right? So we are going to meet live every day on this particular channel, and we're going to discuss some of the important JEE Mains questions, right? So with this we are going to enhance our preparation so that we are actually ready for the upcoming JEE Mains part 2 or the attempt 2, right? And not only for JEE Mains, these questions are also going to be a basic concepts or your ideas for solving the questions of JEE Advanced, right? So stay tuned for this particular thing. So let's get started on this very first topic, and today we're going to start with the algebra part, right? So we have our topic over here and we are going to start with quadratic equation, right? So quadratic equation is a very basic topic for the start of algebra, right? So we have already covered the coordinate geometry, and my target is basically to complete the algebra part, and then I would definitely love to move to calculus, right? Now why did I take up algebra? I know that you must be wondering that the calculus is more weightage or the more priority chapter, but I took up algebra just to make sure that your basics or concept are clear, right? Because you will see when you solve questions of vector and 3D geometry, even if you solve questions of calculus, you will have to use the concepts of algebra, right? And now one more important topic that I haven't started in this particular series, that is trigonometry, right? So trigonometry is also very basic and a important concept that it need to be used up, and you will see that trigonometry concept are just like a salt to food, right? So you just sprinkle it around every food, right? And then the food becomes more tastier, right? So that is what the trigonometry has to play the role, right? So trigonometry is such a concept which is basically has its application almost everywhere, right? So we will take up trigonometry as well, don't worry for that. Okay, so you leave the planning part up to me, and plus just stay for this particular session. Okay, so I wish you all a very welcome to this particular channel. All right, so I hope we can proceed together for this particular content. Okay, so today we're going to discuss the quadratic equation as well as some of the inequalities, and we are going to discuss the top important previous year question that has been asked in your JEE Mains, right? And those are very crucial as well as very helpful for your upcoming mains paper, right? So I will talk about the statistical analysis as well, and with the statistical analysis I will also give you some idea like how you are going to prepare for the paper, right? Now one more important thing is that whenever you are watching this particular session, before starting this particular session, I would request all of you to please go through the chapter notes or short notes. If you have prepared short notes, it is very well advisable to please go through the short notes and prepare the formulas. Okay, so it is always advisable to, before you are coming for the session, you can always go through the formulas at least once, right? So these formulas will be very useful for solving the questions. You will understand that when I take up any question, if you have the formulas in your fingertips, then this will be very easy for solving the problems, right? So with this particular idea, let's get started on this particular session. So today our idea is going to discuss about the concepts of quadratic equations and inequalities. We're going to discuss some of the important concepts. We're going to discuss also the formulas. That will be a revision to all of you, right? Along with that, we are also going to discuss the previous year questions. We're going to practice both MCQ as well as numerical type of questions. We're going to practice the JEE Advanced Integer Based Problem. Now, why I'm talking about JEE Advanced Integer Based Problem, you will understand that many times in JEE Mains, the numerical type or the integer type problems are almost copied from the JEE Advanced problem, right? So if you have already covered the JEE Advanced previous year problems or the integer type problem, that will be a very useful for solving the JEE Mains integer based problem. So I hope you will understand this part and you will get working on that, right? So with this part, let's get started on, and also we will also try to understand and do a statistical analysis of the paper patterns and the paper predictions. Okay, so that is what we are going to do in this particular session. So I wish you just grab a notebook and a pen and just let's get started for this particular session. Please let me know or give me a confirmation that we can start. Give me a confirmation that we can start. All right, so I'm looking through your live chats. If you have any questions, you can definitely put that in the live chat, and with this we can start, right? So please let me know if you have any questions, or else we will start, right? So then let us get started with the very first and the most important basics of a quadratic equation, right? So quadratic equations are a polynomials of degree 2, right? So a polynomial of degree 2 of the type ax square plus bx plus c, where a, b, c are the real numbers and a is not equal to 0, is given as a quadratic polynomial, right? And a is called the leading polynomial or the leading coefficient of the polynomial, right? And c is called the absolute term because it does not has the x for it, right? So it is called the absolute term because if you put x equal to 0, you are going to get the value as equal to c, which determines the absolute value of a particular quadratic equation or quadratic polynomial, right? Now I would like to tell you one very interesting difference is basically whenever you are writing f of x is equals to something, then it is basically a quadratic polynomial, and when you are basically writing f of x equal to some constant or like 0, then it is basically called as equation. So this is called an equation. So unless and until you're equating an expression to some number, then otherwise it is called an expression. Okay, so this is a quadratic expression, right? So this is a very interesting basic concept, okay, that we need to understand before we start on discussing the chapter, right? Similarly, if a is equal to 0 and we have y equals to bx plus c, it's called a linear polynomial. It's called a linear polynomial. And if a equals to 0, b not equals to 0 and c equals to 0, then b equal to y equals to by is called a odd linear polynomial. Because what is an odd function? Odd functions are basically, so discussing about the odd function, you must have studied that is f of minus x, you'll get it as minus of f of x, right? Now that is something called as odd function. You must have studied that in the chapter of functions, right? So similarly, a linear function is basically a linear polynomial is an odd function if c is equal to 0, right? Now a general standard appearance of any general polynomial is basically given by this particular expression. This particular polynomial expression is having the degree as equal to n, right? So degree is basically equal to n, and we have the general appearance like this, right? But the leading coefficient is basically the coefficient of the highest order of x, right? And that particular leading coefficient, should not be equals to 0. Should not be equals to 0. I hope this is clear to all of you, right? Along with that, when the highest coefficient is 3, it is called a cubic polynomial. When the highest coefficient is 4, it is called a biquadratic polynomial, and similarly it goes on, right? So this is what you have to understand in the concept of polynomials. I hope you have already covered this part in your junior classes, right? So we will take up with the part of quadratic expression and quadratic equations, right? So therefore we are going to discuss only with the quadratic equations, right? So first of all, let us see that if we have a quadratic expression y equals to ax square plus bx plus c, so what we can see over here, that we can try to express this in terms of a parabola, right? Because it is like this. So what I can do over here is that if I take our a as common, so this is going to be x square plus b upon a times of x, right, plus c upon a, right? Now I can decompose this further as a times that. Now this thing I can make it a perfect square, as I can write it as x minus b upon 2a whole square of it, x minus b upon 2a whole square of it. Now since I am say for this, it is x square plus minus 2 So I should put a plus over here. X plus b by 2a whole square is basically going to be x square plus b upon a into x plus b square by 4a square. So that thing is added. So I have to subtract that as well. So subtracting b square by 4a square, right? My plus of c by a, and that is what we will have as this particular expression y equals to, right? Now what is the advantage of doing this is basically I am able to express this particular expression in terms of expression like y is equal to, or I should write like the 4ay is equal to x square, and that is our try, because what we can see that this is y equals to some x square, which is a very obvious thing. That is a general equation of a parabola, right? So from this we can see that it is a general equation of parabola with the vertex at x equals to. So any of this general parabola will have the vertex. This is x coordinate of the vertex is going to be minus of b by 2a, right? Minus of b by 2a, and if you put minus of b by 2a, the y value you are going to get is basically going to be b square minus 4ac divided by 4a, right? So that is what you're going to have it over here. So that is it. So for any general, so if we have any general quadratic equation, so it is going to have the vertex at minus b by 2a comma, now this is 4 b square minus 4ac is nothing but you have already studied that in your junior classes, that it is the discriminant of the quadratic equation, right? So it is going to be discriminant of this. Sorry, we will have a minus sign over here because we took a minus of this, right? Yeah, fine. So it is going to be minus of discriminant by 4a. So that is going to be the vertex of the parabola, right? So we will have a parabola y is equal to x square plus bx plus c is going to be a parabola with the major or the axis of the parabola is parallel to the y axis. I hope this is clear to all of you, right? So this part is clear to all of you. Please let me know in the comments or the live chat if something is not clear. Okay, I will repeat it again. All right. So I hope this part is clear to all of you. Then let us take up the understanding. Then what is the different cases, right? Now depending on the value of the leading coefficient, we are going to decide or judge upon whether the parabola is going to be concave up or concave down, right? Now how do we check for concavity up and down? That is something that I already studied in the part of calculus. So I'm basically taking up over here. So in calculus, you must have studied that the second derivative of any particular function, if it is greater than 0, then it is basically talking about concave up, right? So similarly, for this quadratic expression like y is equal to ax plus bx plus c, if I take the second derivative with respect to x, I'll get the value as 2 times of a, right? Now, if our a is greater than 0, so then it is going to be concave up, and if our a is less than 0, then it is going to be concave down. Right, and that is something that you have already studied in the calculus part, right? And if you haven't studied, don't worry, we can come up with the upcoming sessions where we're going to discuss about calculus, and in that upcoming session we're going to definitely discuss about it. Okay, so don't worry, but you can take up this thing for the time being, right? So whenever you have the leading coefficient greater than 0, then you are going to have the parabola opening upwards, and if the leading coefficient is less than 0, then we are going to have the parabola opening downwards, right? I hope this part is clear to all of you. Please let me know, right? So if you're watching this session for the first time, I would definitely request you to subscribe to the particular channel, and please check out all the contents that we have already talked about and discussed in this so far in this content of the series of JEE Mains, right? So for the JEE Mains part, we've already covered a lot of topics, right? And if you're starting from today itself, then I would say definitely go to the channel and watch those sessions starting from straight line itself, right? So if you're not watching the initial session, then you might be feeling like you're missing out on the part that your friends are already covered, right? So don't be that part. So please try to make up for the lost portion. Okay, so you can definitely watch those lost portion as well, right? So let's now focus on this particular part. Now there is something called as discriminant, which is basically given as d, right? So discriminant is basically equals to b square minus 4ac, and depending on this discriminant, whether it is greater than 0 or whether it is less than 0, we are going to decide that the roots are going to be real or whether the roots are going to be an imaginary number or not, right? So depending on the value of the d, what is the value of the d, whether it is positive or negative, we're going to see the cases as, so if your d is greater than 0, then we are going to have two real roots, right? As you can see from here, the intersection. And similarly, if d is equal to 0, then we are only going to have one unique root, that is going to be the vertex of the parabola. And similarly, if d is less than 0, then we are going to have complex roots that we cannot show in the real plane. So we'll just show it by that it is not going to intersect with the x-axis, right? That basically shows that it does not have any real roots, right? Similarly, if a is less than 0, so we can see the concavity is downward, and again the same principle follows over here, right? So d greater than 0 have two real roots, d equal to 0 only one real root, which is a vertex, and d less than 0 it has no real roots, right? So for d less than 0 it got no real roots, right? I hope this part of the quadratic equation is very simple and straightforward to all of you. This part I hope mostly many people are generally completed this part, right? In your junior class as well, you must have seen this part, right? So we just took a recap on this particular part. Now let's work on the next part, and with this let us try to understand what are the different cases that you can see on the type of locations of the quadratic equation. Now locations of the roots of a quadratic equation are an important concept, okay? So you must not leave this part, okay? So location of roots are very important, keeping in mind the JEE Mains curriculum, okay? So location of roots are very important, keeping in mind the JEE Mains curriculum, right? Even for JEE Advanced, the location of roots are also very important, right? So I'm just clearing this part of the explanation over here. Now let's start with the next part. Let's try to discuss about the inequalities that might exist in the quadratic equation as well, right? So let us move forward. So if a is greater than 0 and d is also greater than 0, then we have two real roots, right? Now, if it is said that f of x is greater than 0, then it is obviously that the x is basically lying between minus infinity to alpha and union beta to infinity. That is very obvious from this particular statement, right? So you can just see over here that for this particular interval of x, we are having y as positive, and similarly for beta to infinity, we are again going to have y as positive, right? And similarly, if your a is negative and your d is greater than 0, again, and if f of x is less than 0, then I can see that again the x is basically this particular interval for which I'm having the y as negative, right? So this is very obvious from the diagram. So once you're able to figure out or try to draw the graph of the quadratic equation, then the things are going to be really simple, right? So next concept is basically if a is greater than 0 and d is equal to 0, that means basically alpha is equal to beta. And if I talk about that f of x greater than 0, then it is true for all x belongs to real integer, right? Real number, not integer, sorry, real number, right? And for x alpha, we are going to have it at 0. So why is alpha? Alpha is a root or the vertex. Okay, vertex of the parabola, which is nothing but equals to minus of b upon 2a, which is nothing but minus of b upon 2a, right? And then we are going to have now if your quadratic equation a is negative and d is equal to 0, and the equation is given something like this, and f of x is less than 0 for all x not equal to alpha, because I'm less than 0, and at f of x equal to alpha, we're going to have it is equal to 0, right? So this is very simple. Once you are able to figure out the graph, you're going to get the understanding, right? Next is to also understand that now this case is going to be really interesting. That is, sometimes you will give a quadratic equation like ax square plus bx plus c, and you will be asked to find out the interval of y or the interval of x for which the y is always positive, right? So if y is always greater than 0, and if I have a greater than 0, then and d is greater, so that is the only condition that I will have our discriminant should be less than 0, right? So it is only possible when our discriminant is less than 0. So our discriminant is less than 0, then, and if a is greater than 0 and I need to have y greater than 0, y is always positive. That is only possible when our discriminant is less than 0, right? And similarly, if your a is negative and then you want to find out the y always negative, that is also the case when your discriminant is also less than 0, right? So these two cases depending on the value of a, so this is a less than 0 and this is the case a greater than 0, right? So depending on the values of a or the leading coefficient of the polynomial, you are going to generate these different sets of equations involving the quadratic expression, right? So you will definitely have multiple variables, and with that variables you are going to find out what are the expression for that involving that variable, given that y is always positive, y is always negative, right? So that is something that you have to do up in this particular chapter, right? So I hope this part is clear to all of you. It's just about graph, right? So once you understand the graph, you are basically going to get the rest part very easy, right? Please let me know if this is not clear or not. So let's proceed then. Alright, so let us proceed with the next part then. So we have with us, the next part is basically involving the theory of equations, right? Now this is something very useful, like very important as well as very useful for all of you, right? So let us try to understand that whenever you are given any general nth degree polynomial expression such that, so for the nth degree polynomial expression, it must have it must have it must have n number of real roots. Yes, Goku, what happened? Right, if you're not interested, you can leave. Why are you asking me to leave? I'm basically helping out people like those who are really want to practice or prepare for JEE Mains, right? And if you're suddenly coming out of nowhere, why should I leave? You should just leave it. Okay. All right. So that's it. Right. So fine. Let us try to understand the next part is basically I'm talking about that whenever I have a nth degree polynomial expression and it is equal to something that is an nth degree polynomial equation, and I need to find out. So given condition is that whenever in a nth degree polynomial, given that all the coefficients of the x or variables are basically real numbers, then I'm going to have n number of real roots. Right. Now there is a very interesting part to understand over here is that if you need to find out the summation of the roots, if you need to find out the summation of the root, it is basically given as minus of a1 by a0, that is the coefficient of x to the power n minus 1 divided by x to the power n. Similarly, if you need to find out the summation of the product of the roots, or that is taken 2 at a time, summation of the product of the root taken 2 at a time, it is basically given as a2 by a0, that is coefficient of x to the power n minus 1 divided by x to the power n, or the coefficient of x to the power n, right? And similarly, you want to find the summation of product of the root taken 3 at a time, that is given by minus of a3 upon a0. So that is basically minus of coefficient of x to the power n minus 1 divided by coefficient of x to the power n. Right. I hope this is clear to all of you. So then now similarly as a thumb of rule, it is basically when you're taking the sum of the roots taken all at a time, or basically n number of roots at a time. So it is basically write this. So let me write the general expression over here. So a general expression like this, x1, x2 and so on up to x of r, right? Where our r is less than n, right? Or less than or equal to n. And if you want to take the summation of all these roots taken r number of times, or the product of the roots taken r times, then it is basically given as minus 1 to the power r, minus 1 to the power r, coefficient of x to the power, coefficient of x to the power n minus r, coefficient of x to the power n minus r divided by coefficient of x to the power n, right? That is how you are going to generalize or find out the product of the roots, sum of the roots. So if you are asked the simple questions about the summation of the roots taken 1 at a time, summation of the root with the product taken 2 at a time, summation of the roots taken 3 at product taken 3 at a time. So that is how we are going to approach these kinds of problem, right? So I hope this particular thing is clear to all of you. Please let me know in the live chat, is this clear or not? Well, so this is basically, see, now you can try to understand that whatever content I'm providing are very crucial for your upcoming JEE Mains, right? So if you just try to follow this particular session clearly and understand every part of it, you're going to do really well in your upcoming JEE Mains examination, right? So if you have any questions, you can definitely put that up, okay? So if you're not even interested to watch this particular, you can definitely leave otherwise. But if you try to understand something, you will get a lot of things from this particular sessions. Okay, these sessions are just for free on this YouTube, and if you're just practicing from this particular session, you're going to get a lot of benefit. Okay, so and you will definitely thank me later once your JEE Mains is over, right? You will see that most of the questions are basically the same concept or the topic that I have already discussed in this particular session. Okay, so stay tuned for this particular session, and please try to be with the session till the end. All right. So please let me know if anything is not clear, or should I repeat it again? All right. Right. And if you're feeling these lectures are going to be really useful, you can also try to send and share these videos among your friends as well, so that your friends also join with this particular session and they also come up live and we can also solve questions together, right? So let's get working on the next concept, and with this next concept is basically the relations of roots, because mostly in this particular chapter, as we start solving the questions, you're going to definitely see that mostly we are going to work on calculating the transformation or the relation among the roots with the coefficients of the quadratic equations, right? So that is what we are going to mostly see in this particular chapter. So let us try to understand what are the different relations that might exist, right? So I've taken out something for you, all of you. Okay, if you try to remember it, it's going to be really useful. You can always opt out for not remembering it as well, right? But I have given out this particular concept because this is going to be used mostly or repeatedly in the concepts or the questions that we're going to see over here, right? So the very first thing is that if the roots of a quadratic equations are given as alpha and beta, such that the quadratic equation is given like this way, okay, and alpha and beta are the roots such that a is not equal to 0, then your alpha minus beta is basically given as plus minus square root of alpha plus beta whole square minus of 4 alpha beta, which you can solve it and you will find this is nothing but square root of discriminant by a, or the leading coefficient, right? Then this is very important. You'll see in many of the questions they will be asking you to find the absolute value of the difference of the roots, right, from a given quadratic equation. So for that particular concept, this is going to be really useful, right? So let us not proceed with the next part. Next part is that if you have to find out alpha square plus beta square, that is going to be equal to alpha plus beta whole square minus 2ab, right? Which is basically given as b square minus 2ac divided by a square, right? Then if you need to find out alpha square minus beta square, which is nothing but alpha minus beta into alpha plus beta, right? So if you just apply this, you will get the value as plus or minus b into square root of b square minus 4ac divided by a square, right? And similarly, if you need to find out alpha cube plus beta cube, that is basically given as alpha plus beta whole square minus 3 alpha beta into alpha plus beta, and which will basically generate you the answer as b into b square minus 3ac divided by a cube, right? So this should be cube over here, okay? Similarly, alpha cube minus beta cube is going to give you the answer alpha minus beta whole cube plus alpha beta into alpha minus beta, and that is going to generate you the result as plus or minus b square minus 4 ac into square root of b square minus 4ac, that is nothing but discriminant divided by a cube, right? Similarly, if you need to find out alpha to the power 4 plus beta to the power 4, that you can simply find it as alpha square plus beta square whole square minus 2 times of alpha square beta square, right? So this is going to generate the result like this. Similarly, alpha to the power 4 minus beta to the power 4 is going to give you the result like this. You can just always try to find out this by just putting this earlier expression into the old equations, right? Similarly, if you need to find out alpha square plus beta square, that is nothing but alpha plus beta whole square minus alpha beta, which you can simplify by this, right? And if you need to find out alpha square beta plus beta square alpha, it is just simply as minus bc divided by a square. And similarly, if you need to find alpha by beta whole square plus beta by alpha whole square, that is going to found out by like this, right? B square minus 2ac divided by ac whole square of it minus of 2. I hope this part is clear to all of you. Please let me know in the live chat if this is not clear. Alright, so this is just for your benefit of solving the question. So once we take up questions, we are going to see that most of this particular part is going to play an important role. Alright, so please let me know if it's clear or not. Alright, so let us start with the question solving. So let's work on the solving the questions, right? So with this, we have the first problem on our, so before we move to the questions, now one more concept or the topic that is also really important, that is basically nature of the roots, right? So nature of the roots is really important. Now, if you have someone who have already covered the applications of derivative part, then it might be very easy for you to understand this nature of the roots easily, right? What is nature of the roots talking about? So it is more of like calculus based, or if you try to apply the applications of derivative, it is more related to the finding the roots of a given equation, of a given any general equations, right? So what we generally do in the chapter of application of derivative is that we try to find out, so for a given equation like this, so for a given equation like y is equal to f of x, what for first of and foremost thing, like whenever we need to find out that y is equal to f of x is equal to 0, now if you need to find out the number of roots, okay, so if you need to find out the roots, what we do in general is that first of all, we try to plot the graph of this particular function y is equal to f of x, right? We try to plot the graph of this function is that by now, I will teach you this graph plotting thing in a separate class. Now that is a totally separate concept. Okay, now that is a very interesting concept. Now when I was a student, I really used to feel that graphical concepts or the plotting the graph questions using the applications of derivative is really an useful concept, right? So what we do, we try to find out the value of the function at 0, at plus of infinity, and at minus infinity, right? And that will give you an idea about the bound of the function. Now x equal to 0, finding out the value of the function at x equal to 0 is a really easy task. That's why I asked you to find the value at these three important points, right? At these three important points, especially x equal to 0, x tending to plus infinity, x tending to minus infinity, right? Now we cannot find out the exact value of the plus infinity and minus infinity. What we're going to use, we are going to use the concept of limit, right? And similarly, if you're not able to find the value of x equal to 0, we're again going to use the concept of limit to find the value of x equal to 0, right? Now we check for the increasing and decreasing nature of the function. Now how do we check for increasing decreasing nature? That we have already discussed. We'll discuss in the chapter of application of derivative. But if you try to understand, if f dash of x greater than or equal to 0, it is an increasing function, and if I have f dash of x less than 0, then it is a decreasing function, right? So based on this particular notation, we're going to find out the interval of x in which the particular function y equal to f of x is increasing, and in that particular, and in which interval of x we are having this y equals to f of x as a decreasing function, right? So once we get that particular idea, then while we equate f of x equal to 0, we'll get some of the critical points, right? We'll get critical points. Now critical points are those points around which I'm going to have either maxima or either minima, or either we are going to have point of inflection, right? That is, you will study all this part in the chapter of applications of derivative, right? So I hope this part is clear to all of you. Now once we understand about the nature of this particular question, all right Nitish, I hope you understand this part. All right, so yeah, thank you Nitish for watching this particular lecture. Okay, stay tuned for this particular session, and you will definitely going to get a lot of benefit while watching this particular session. Okay, all right, so I hope you are following me. Okay, so I hope you are on the same note with me. So then once we understand this part, now if we need to find out the number of roots, we will try to recollect on the Rolle's theorem. What does Rolle's theorem has to talk about? Is that if I have a particular interval in which this particular function is defined, such that let us say that within the interval x equals to a to x equals to b, a particular function is defined, right? Now if I have the value of the function at the endpoints, now if I have the value of the function at the endpoints are equal, so let us say if I have the value of the function at f of a and f of b they are equal, then I'm going to have a point then for c which is lying between a comma b, such that f dash of c is equal to 0. So I will definitely have one point c which is lying between a to b, such that that particular derivative or the slope of the function is going to be equal to 0. I hope this part is clear. Now this is basically from the Rolle's theorem. That is, now using the Rolle's theorem, we can definitely discuss about the nature of the roots of a polynomial expression, right? So from this particular part, then we also talk about the increasing concavity nature of the function, and once we get all the information, we are basically in a position to draw the graph of the function. And from the graph of the function, like let us say the graph of the function looks like this. For this is one of the critical point, this is one of the critical point, right? So this C1, this C2. So from these two critical points, and analysis of this will basically yield us all the important location of the roots, right? So from here we can see that x, this particular part is a root, this particular part is a root, and this is root, right? So we're going to definitely analyze the question by trying to draw the graph of the function, and from the graph of the function we are going to find out the number of roots for the given case y is equal to 0, or y is equal to f of x is equal to 0. Right, and even if you equate this to some constant c1 or c2, we can try to equate that by taking out the y value over here and then find the point of intersection with the given y, right? That will also give you the number of roots for the particular same case, right? I hope this is clear to all of you. Right, now what we do, now if a function is an increasing function within a particular domain a to b, and it is said that f of x equal to 0, then it will have at most one root, then it will definitely have at most one root in a comma b. That is from the statement of Lagrange's mean value theorem. Okay, now if f is equal to 0 be a polynomial equation and a and b be two real numbers, such that f of x equal to 0 will have at least one real root or an odd number of real points in a comma b, inside a comma b, if f of a and f of b are of opposite sign. So if I have f of a into f of a negative, that means they are of opposite sign, then we will definitely have at least one real root or a odd number of real roots, at least one real root or odd number of real roots inside the interval lying from x equal to a to x equal to b, what you can see from this particular graph over here. I hope this is clear to all of you. Right, please let me know if something is not clear, otherwise I will repeat it again. All right, so I hope this part is pretty straightforward. Okay, so now if I try to see that if f of a and f of b are of the same sign, then that is if I have f of a into f of b is greater than 0, then either f of x will have one real root or an even number of real root. Right, it will either have one real root or it will have even number of real root. So one real root, sorry, it will have no real root, so there should be no real root. Okay, so this should have no real root, right? This should have either no real root or it will have even number of real roots, what you can see from the graph over here. So if I have the values of the endpoint, the functional value at the endpoint of the graph is positive, then I am going to have at least no real root or either I will having even number of real roots. Right, I hope this part is clear to all of you. Right, I hope this part is clear to all of you. So this is all what we need to discuss about the nature of the roots for the polynomial equations. Right, with this we are ready to start with our very first problem from our JEE Mains previous year question. Right, so I would request all of you to please look this particular problem and try to solve it, at least give it a try, and if you're not getting, I'm going to help you out with this particular problem. Right, so you can pause the video at this particular moment and you can try it by yourself. Right, so let us see what the question has to talk about. Okay, so you can always pause the video and move with the solution, right? And if you are able to solve it faster than me, you can definitely let me know the answer you are getting in the live chat. Right, so let us try to understand what this question is talking about. Right, so the question is talking about that for a given the given equation, that is our given equation is given as 2x square plus a minus 5 times of x plus of 15 is equals to 3a. Right, and this is saying that it has no real roots. Right, if it is having no real roots, then let us try to make this a quadratic equation like this, that is a 2x square plus a minus 5 times of x plus 15 minus 3 times of a and equating to 0. And if it is having no real roots, then this particular equation has no real roots, which is basically given as discriminant of this particular equation should be less than 0. As simple as that. Now once we try to equate the discriminant less than 0, then we are going to have a condition or an interval in a. Right, so let us try to see it. So it is saying that it has no real root inside this interval alpha comma beta. So let us try to understand this. So from here our discriminant is going to be a minus 5 whole square minus 4 times the 2 into 15 minus 3a should be less than 0. I hope this part is clear. Now proceeding further, what I can do it over here is that let us try to solve this general equation. So I will have, so on squaring this part, I will be having a square plus 14, right? A square plus 14 and 14a. Okay, so I'm just trying to simplify this part. This part is going to be 10 of a, right? And this from here I will have plus of 8 into 3, that is going to 24. 24 minus 10 is going to give you plus of 14a, and I'm going to have the constant as 25 minus 120 should be negative. Right, should be negative. That's what we are having. Now on further simplification, I will have it a square plus 14a minus 95 should be less than 0. I hope this is clear. Right, so once we have this, then on further simplifying, so what I can see, I can just take two roots. Okay, I will just factorize this particular expression, and I can factorize this particular expression as, so this is 19 and 5 are going to be the two roots, so plus 19 and minus 5. So I'm going to have a plus 19 multiplied with a minus 5 is less than 0. Right, so that is what we will have it over here. So our inequality gets changed to a plus 19 multiplied with a minus 5 is less than 0. Right, so now with this particular part, we can find out our a or our inequality. Now we have already discussed about this inequality, that is when our particular quadratic is less than 0, and I need to find out that, so it is something like this. So this is a quadratic in a. So we need to find out the value like this, which is basically between minus of 19 and 5 over here, right? So for the value inside this root minus 19 and 5, I'm going to have this particular expression. This expression as negative, right? So from here, I will have a value of a to be lying between minus 19 comma 5, right? So minus 19 comma 5 will be the bound of a, right? Now once I have the bound of a, our next part of the question is talking about there is a set x, capital X, that is talking about that small x belongs to complex number z. Any z is basically, so not is a complex number, it's an integer number. Extremely sorry, z is an integer over here, such that our x is lying between alpha and beta, right? So we just need to find the summation of square or the sum of all the small x or the elements of the set capital X, right? So from here, what we'll find out that our x is basically lying between, so for x between, so our small x is basically, so the elements of the set, okay, these are the elements of the set, because for the values of a between minus 19 and 5, I'm going to have it as the required solution to exist, right? That will, my quadratic equation will have no real roots, right? So once I have the elements of the, and these all elements are basically belonging to integer, right? So from this, if I try to find out the sum of the square of all the integer x inside this set x, then this is going to be 1 square plus 2 square plus 3 square plus 4 square, right? And the remaining negative, and square of the negative is going to be again positive, and that is going to yield you minus 1 square, that is going to be 1 square, minus 2 square, that is going to be 2 square, right? And so on up to minus of 19 square, right? So we already know the formula for sum of the square of the n number of natural number, that is basically given as 4 into 5 into, so this is basically given as n into n plus 1 into 2n plus 1 by 6, right? So from here I will get this relation as 4 into 5 into 9 divided by 6 plus 18 into 19 into 37 divided by 6, right? So from this part, if you try to simplify this part out, so if you just try to simplify this part out, you will find this relation as 30, and this part will come out as 2109, which will generate me the answer to my particular summation of all the square of the element is going to be equal to 2139, and that is going to be the answer for this particular problem over here. So that is, we have the answer as option number A, that is 2139. I hope this is clear to all of you. So with this, I will have our solution to this particular problem as option number A. So I hope this part is clear to all of you. Please let me know if something is not clear, otherwise I will repeat it again, right? So this part is clear to all of you. Is this part clear to all of you? All right, so let's proceed with the next question then. So once this part of the question is clear to all of you, we can proceed with the next problem as well, right? So our next problem is again an interesting problem, that is where we have to find out the number of solution for a given equation, right? Now not always you will be given a quadratic equations, right? So sometimes you will be given some broken expressions, and from that broken expression you have to find out the number of solution, right? So let us try to simplify this expression and then we proceed with the number of solution for it, right? So what we'll see over here, that the given expression, so from this particular given expression, what I'm going to do is over here, now looking at 1 upon square root of x, let us try to proceed by putting 1 upon square root of x as some alpha, right? Now since it is a square root of x, so it is going to be definitely greater than 0. So our alpha should be greater than 0. Right? Now once we have, and because x is greater than 0, so I will also have so alpha will be definitely greater than 0. So x is greater than 0, that means we are talking about the real x, right? The real solutions of alpha, right? Okay, so once we are able to write this expression like 1 by square root of x is equal to alpha, then I can decompose this particular given expression as 9 times of alpha square minus 9 alpha plus 2 multiplied with 2 alpha square minus 7 alpha plus 3 is equal to 0, right? I hope this part is clear, right? Now what I'm going to do it over here is that I'm trying to factorize this given individual quadratic equation in terms of alpha. So what I can see, I can just try to factorize this part out as 3 alpha minus 2, and this will basically become 3 alpha minus of 1. So this is basically the decomposition of the first quadratic expression, right? Similarly, the second quadratic expression will be factorized it as, so very simple, we'll have the roots as alpha minus 3 and alpha 2 alpha minus 1. These are going to be the factors for this particular expression, right? And we have to equate that to equal to 0. So from here, we'll value of alphas as 1 upon 3, 1 upon 2, 2 upon 3, and we'll have it equal to 3. So these are going to be the values of the alpha expression, right? So once we have the value of alpha, we are always in a position to find out x, and from here we'll find the x as 9, 4, and this is going to be 9 upon 4, and this is going to be 1 upon 9. So what we can see that our number of x from this particular equation is going to be equal to 4 roots. So we are going to have 4 roots for this particular expression. I hope this is clear to all of you, right? Very straightforward problem, but the idea is very intriguing, right? That's why I took up this problem, right? This idea is very interesting because you have to discuss about why we are basically doing transformation, not keeping in the answer in terms of root x, but we are transforming into some other variable such that we are able to figure out this quadratic equation into a biquadratic equation, and we are going to easily find out the roots. Very simple, right? I hope this part is clear to all of you. Please let me know if this is not clear or okay. So I hope you are also following the questions with me, and I hope you got this particular part over here. You can always put the question in the live chat. I am definitely going through your questions, okay? And if you're someone who is watching this session after the live is over, you can always put the question in the comment section. So it is a summer season. I would request all of you to please stay healthy, okay? Try to drink enough water, okay? Keep on drinking water so as to stay hydrated, okay? So that you don't feel dehydrated and your preparation is hampered by any of the problem, okay? So something that you need to take care of, right? Because it is very humid and warm in all over most places of India, right? So please take care of your health, and I would also say that make health as your first priority, because ultimately if you're not good in health in the day of the exam, you're not going to perform well, right? So please try to have a good night's sleep. At least try to have 7 hours of sleep daily, right? Do not feel nervous for any preparation, or do not feel like extra hour of your cutting of your sleep will give you extra preparation. Now that preparation won't be help up, because once if you're not fit or good in health, you're not going to do well in the exam as well, right? So please make sure that you keep up this particular part, and please take care of your health, okay? Please try to have a very good sleep. Please try to eat healthy, okay? So that will actually help up for your preparation also. And one more idea that I would like to give all of you is that once you're practicing the mock test, while you're practicing the mock test, try to practice the mock test as if you're giving within the frame of your time limit on the JEE Mains examination, right? So your JEE Mains examination, a standard examination timing is basically 9 to 12 and 2 to 5. So always try to keep at least your mock test from 9 to 12 or within the time frame of 2 to 5, so that you are able to adjust your biological clock according to that particular part. All right. So I hope this is clear to all of you. Okay, and if you're someone who is preparing for this particular JEE Mains second attempt, as well as those who want to get a personalized one-to-one interaction from me and want to understand and want to get their doubts clear, you can always go for that. So in the description of this particular session, you'll find out the contact details of that, okay? So for one-to-one or group tuitions, you can definitely contact the undersigned numbers, okay? And there is a Telegram group. You can always join the Telegram group for the upcoming notification as well as batch notification that we are going to come up with, right? So let's work on the next problem. So with this, we have our next problem, and this question is really interesting, right? If you don't know the concept behind this question, you're going to look into the exam and come out of the exam even without solving this problem, right? Now this is a very interesting problem. This is one of the functional equation, and this functional equation in terms of a quadratic expression. That's why I took up this problem, right? So let us try to understand how we are going to look or solve this particular problem, right? So it is said that if I have a functional expression such that it is taking up all real numbers except 0, and it is going from the range minus infinity to 1, right? Now this is said that it is the function f is a polynomial expression of degree 2. It is a polynomial of degree 2. So it's a polynomial of degree 2 such that it is satisfying a functional expression given as f of x multiplied with f of 1 upon x is equals to f of x plus f of 1 upon x, right? So that is the functional equation. We have it with us, right? So let us consider, so given that is a polynomial of degree 2, we can always assume, or let us assume f of x is equals to some polynomial of degree 2, that is ax square plus bx plus c, right? Such that our a is not equal to 0. Now why I'm putting a not equal to 0? Because our highest degree should be greater over there, right? Because it is an order 2, so you must have the leading coefficient non-zero, right? Now once we have this particular information, I have to put that back into the functional equation. So on satisfying the given criteria, that is f of x into 1 upon x is equals to f of x plus 1 upon x, what I will find out is that, now once I try to put f of x into f of 1 by x, I will get this relation as a x square plus bx plus c multiplied with a by x square plus b by x plus c, and this is basically equal to f of x plus f of 1 by x, that is going to be equal to a x square plus bx plus c excuse me, sorry for that, plus a by x square plus b by x plus c, right? So from this particular expression, if we try to simplify, we'll get a important relation, that is our constant part c is going to be equal to 1. Our constant part c is going to be equal to 1. What you can always do, you can try to simplify this part. This you can just multiply, okay, and equate to this particular case, and you just try to simplify this part, and you will get that our c should be equal to 1. And also I will get one more information, that is our a should be equal to plus or minus 1. So with this particular expression, now this is a very standard functional equation. So this standard functional equation will must have the form. So whenever you see standard functional equation like f of x into f of 1 plus x is equals to f of x plus f of 1 plus x, it is always advisable to remember that our functional equation is going to be x equal to 1 plus minus x to the power n, right? But since in this particular problem we are given the order is 2, so we have to put the n is equal to 2 from here, and we'll get our functional expression as x equal to 1 plus minus f of x equal to 1 plus minus x to the power 2, right? Right, and that is very obvious from this particular statement over here, right? Once we find out the value of a as well as c, we are also seeing the same value, right? So now proceeding further, we have to check that the functional expression is having the range. The range of the functional expression is basically within minus infinity to 1. So it is taking up at maximum is 1 and minimum is minus of infinity, right? So that means that if I take the positive sign over here, that won't generate me the given range, that is minus infinity to 1. But if I take the negative sign over here, then it will definitely have the range minus infinity to 1, right? So from this, I will get our given or our only f of x or function of value of x is basically equals to 1 minus x square. So from this, I will get the function x in x is basically equal to 1 minus x square. Now it is said that if your value f of k is equals to minus 2k square is equal, minus 2k, if a value is equal to minus of 2k, then you have to equate this to find out the value of k, that is 1 minus k square is equal to 2k, and from this I will get the relation as k square minus 2k minus of 1 is equals to 0, right? So if the roots of this particular equation be alpha and beta, that is what is said, so you have to find out the square of all possible values of k. So all possible values of k means all the possible roots of k. So if I consider this is a quadratic equation, so it will have only 2 roots, or it might have 1 root, or it had no root, right? So if it has 2 roots, right, depending, so if it has 2 roots alpha and beta, because any general equation or polynomial expression in order n will have n number of roots, right? So it will have 2 number of roots. So these 2 roots, so we need to find out the value of square of the sum of the possible values, that is basically alpha square plus beta square, and that is nothing but alpha plus beta whole square minus 2 alpha beta, so which we can always try to put it back into the expression. So alpha plus beta is basically equal to minus of b upon a from the original quadratic equation, that is ax square plus bx plus c. So we will see that this is basically coming out as 2 squared minus 2 times of 1 or minus of 1, right, which we are going to have the answer as equal to 6. So from this, the sum of the square of all possible values of k is going to be equal to option number C, that is 6. I hope this is clear to all of you. So with this, we will have option number C as our correct answer. Please let me know if it is not clear. I will repeat it again. Okay, so this is very straightforward problem. So just we are basically using the simple principle, right? Yeah, thank you. Thank you, Reena. Thank you, Reena, for your lovely comments. Okay, thank you. At least someone is understanding my effort and basically they are trying to follow the content, right? Oh, oh, Reena, come on, come on. All right, that is a nice comment. Okay, I will think of that. Okay. All right. All right. So shall we proceed with the next problem then? So I hope this is clear to all of you. Please let me know if it is clear or not. Please let me know if this is clear or not. All right. I'm looking through your live chat. Please let me know if you have any questions. All right. So this part is very straightforward, right? We are basically applying a given functional equation, and from the functional equation, we are trying to predict what is going to be the correct function, right? So that is very simple problem. Okay. Now, if you have this types of question coming up in the upcoming session, you can always try to remember this particular formula. That is, whenever you have the functional expression like f of x plus multiplied with 1 upon x is equals to f of x plus 1 upon x, then our functional expression is basically 1 plus minus x to the power n, and that is very standard result. Okay, please try to remember this result. It's going to be very useful for your upcoming sessions or the concepts of your JEE advanced as well, right? All right. All right. So I hope this is clear to all of you. All right. That's good. That's good, Reena. Okay, and you can always put this particular part as a concept in your formula sheet as well. Okay, so if you are watching this session and if you have prepared some kind of short notes, you can definitely write that part in your short notes as well. So whenever you have a function expression like this, your given function should be like this. Okay, so this I ask you to please write that in your formula sheet. Okay, this will be really useful. All right, Rina, is it clear? All right, so let's start with the next problem. The next problem is really interesting problem and an easy problem, right? It is, I took this problem to make sure that you understand the concept that whenever you have a modulus function in the quadratic equations, and how do you are basically going to segregate the roots based on this particular thing, right? So here you have to consider some cases and then we need to proceed with the problem, right? So if you just look into the problem, so what we can see that there is the given equation is basically x square plus 2x minus 3 mod of it, 2x minus of 3 mod of that minus of 4 is equals to 0, right? So that is the expression we have in the given problem, right? Now once we have this expression over here, so now based on, now I will tell you about that, the modulus function. This is called the modulus function. Okay, modulus function, or what we call as the absolute value function, right? Modulus function, right? So whenever we have the modulus function, it is basically having multiple definition. That is, it is a piecewise different function. It is basically equals to x when it is basically equals to x when the value of, when the value of x is greater than or equal to 0, and it is equal to minus of x when our x is less than 0, right? So this semicolon, so it is equal to x when x is greater than 0, greater than or equal to 0, and it is equal to minus of x when x is less than 0, right? So let us try to move forward with this particular thing over here. Then if you look it over here, that is 2x minus 1 minus 3, and mod of it will have two definitions given as 2x minus of 3 for x greater than 3 by 2, greater than or equal to 3 by 2, and it will be having minus of 2x minus 3 when x is less than 3 by 2, right? So depending on the interval in which the x is lying between, we'll have multiple definition of this modulus function, right? So let us take one of the cases and let us try to proceed with the solution over here, right? So if I take the first case where x is greater than or equal to 3 upon 2, then this modular function will be equal to simply equal to 2x minus 3. So from this, I'll get the quadratic equation as x square plus 2x minus of 3 minus of 4 is equal to 0. Right. Now with this, we'll have our solution as x square plus 2x minus of 7 is equal to 0. Right. So we'll have our solution as x square plus 2x minus 7 is equals to 0. Now if I try to see the solution of this particular problem from here, so from here, let us try to check what is the answer we are getting, right? So for this case, if you try to find out the solution, I'll get one solution as x is equals to plus 2 square root 2 minus of 1, and one of the solution I will have it as minus of 2 root 2 minus of 1, right? So these are the two solutions that I will have it over here. Now you will see that this particular value is basically a negative value which is not greater than 3 by 2. So I cannot consider this particular value because our x is greater than 3 by 2. And this particular part of the solution is actually greater than 3 by 2. So I will consider only one solution from here, right? So for this particular expression, I will have only one solution, right? So this is one of the roots for the given condition, right? Now, similarly for the next case, so similarly for the second case, when our x is less than 3 by 2, similarly for the next case, when our x is less than 3 by 2, I'll have the given quadratic equation as x square plus of 3 minus of 2 minus of 4 is equals to 0, which will give me the case x square minus 2x minus of 1 is equals to 0, which will give me the answer as 1 minus square root 2 or 1 plus square root 2, right? But since x should be less than root 3 by 2, so therefore the only solution should be x equals to 1 minus square root 2. So this should be another solution. This should not be the solution. So we have one more solution from here as x equals to 1 minus square root 2. So we have two solutions, as one of the solution is x equals to 2 root 2 minus 1, and another solution is 1 minus square root of 2. So we are ultimately going to find out the sum of the square of all the roots. So sum of the square of all the roots. So let us call this root as x1 and this particular root as x2. So I have to just find out x1 square plus x2 square, right? And that is going to give me 2 root 2 minus 1 whole square plus 1 minus root 2 whole square. And we can simplify this out easily, and this is going to be 8 minus 4 root 2 plus of 1 plus this is going to be 2 minus of 2 root 2. So what we can see from here, our solution is going to simplify it as 12 minus 6 root 2, which I can always write it as 6 times 2 minus root 2. 6 minus 2 minus root 2. That is going to be the required answer for the sum of the square of the roots for this particular solution, right? Now, if you are someone who is basically trying to find the sum of the square of all the roots by just getting this equation, and then you find out the x1 square plus x2 square from that relation, that is alpha plus beta whole square minus 2 times of alpha beta, then you are going to get the wrong answer, because here the value of x is very case sensitive, because it is a quadratic function given that it is a piecewise different quadratic function. So for one particular interval of x, it has one definition, and for other particular interval of x, it has other different definition. So based on the definition and the inequality or the case where the x is trying to fall into, we are going to have different values of the quadratic expression. So based on the quadratic expression, we are going to have the different root as well. So ultimately this particular quadratic expression is going to have only two roots, and the sum of the square of the two roots are going to be equal to 6 into 2 minus square root of 2. That is going to be option number A from this particular option question, right? So I hope this particular problem is clear to all of you. This is a very interesting problem. Please try to star mark this problem, okay? Now these types of problems are very crucial for your JEE Mains as well, okay? Please try to star mark this problem, and please make sure that you revise this question before going out for your JEE Mains actual exam, right? Please let me know if this is clear or not. If this is clear or not, please let me know. I hope this part is clear to all of you, right? I hope this part is clear to all of you. So this question is clear. So I hope you are able to solve this question easily, right? All right. So I'm going through your live chats. Please let me know if you have any questions or not. Otherwise, we will proceed with the next problem then. All right. So this problem is clear to all of you. Then we have our next problem. And this problem is really interesting. Now, to solve this particular problem, I would say, please try to make use of the graphical transformation graph. Okay, try to draw the graph and try to predict what are the number of real roots, because you are not going to find out the real roots. Instead, you have to find out the number of real roots for this particular equation, right? Please give it a try. So please give it a try. It will be worth giving a try. So if you just try to solve it, you'll try to get something. Okay. And this is really interesting. All right. So let's work on this question. So the question talks about that we have a given equation, that is x square plus 3x plus 2 is equals to something minimum of either 3 minus x mod of it or minimum of x plus 2 mod of it. So depending on the region where the x is lying up, we will have different definition for the minimum of this particular thing, right? So let us try to proceed this question by trying to draw the graph. Okay, so if we just try to draw the graph of x minus 3 mod of it, it is going to be like this. That is straight line like this, right? So this is basically mod of x minus 3, and mod of x plus 2 is going to be like this, right? It is obviously not going to intersect the same point. So let me correct this something over here, right? So if you put x equals 0, it's going to be equal to 2, and if you put x equal to 0 for this case, you're going to get 3. Right. So if you just look it over here, we need to find out the minimum of it, right? So what you can see that for x basically going from minus infinity to at this particular location, let us call this location as x1. For this particular interval, we see that x plus 2 mod of it is the minimum of it, right? And similarly, for this remaining case, the x minus 3 mod of it is going to be the minimum, right? So for x less than x1, our x plus 2 mod of it is the minimum, and for x greater than x1, our x minus 3 mod of it is going to be the minimum, right? So now depending on the x1, so let us try to find out the x1. So if you just try to find out the x1, so from this particular graph we will have the equation of x plus 2, and from this particular line we'll have the equation of this line as 3 minus of x, right? So we just try to find out the point of intersection of these two curves, 3 minus x is equal to, so what we're going to do, we're going to try to equate 3 minus x is equals to 2 plus x. So from here I'll have x equals to 5 upon 2. So depending that x1, so let us call this x1, so I will have this x1 as equals to 5 upon 2. So that particular x1 is equals to 5 upon 2. So depending on the value of this 5 upon 2, I'll have different definition, right? Now, so let us try to solve it over here by taking two cases. Now, these case making problems are really important, because you can see that this type of question where you have to make the cases has already been asked many times in your JEE Mains part. So please make sure that you revise this particular concept before you are going for your JEE Mains second attempt. All right. So this is also over here. So if our x is less than 5 upon 2, if our x is less than 5 upon 2, then I will have this equation 3x x square plus 3x plus 2 will be equated towards x plus 2 mod of it, right? Now if x is less than 5 upon 2, what here we'll have two definition. If x is greater than or equal to 2, then it is positive, and if x is negative, less than 2, then it is negative of it, right? So we'll open up in negative, but what we see, it is less than 5 by 2, which is basically So for solving this question, what I would say, instead of doing or making again cases or sub cases over here, what you can do, you can make two cases again. Okay, that is case A when x is greater than 2 and case B when x is less than 2, right? But instead of making cases over here, I'm going to solve it by taking the graph. I'm going to solve it by taking the graph. So what we see, that this particular quadratic equation will have roots as plus of 2 and plus of 1, which are basically 1 and 2, right? And I will have the quadratic equation like this, right? And this x plus 2 will have the equal. Now I will have to find out only between 5 by 2, right? And 5 by 2 is basically 2.5, right? So this is basically within the limit. So from here I can see our graph is like this, right? And I need to find out. So from here what you can see, that this particular curve intersects this particular curve within this interval. So let us try to find out this particular curve intersected which 2 points, right? And is it that point is beyond 5 by 2 or is it within 5 by 2? That is what we have to check, right? So if I put this expression x equal to 2 is equals to x square plus 3x plus of 2. So from this I'll have the expression as x square plus 2 is equal to 0, right? So with this I will have two roots, x equal to 0, that means it is intersecting at 0, and x equal to 2 over here, and x equal to 2, right? So we'll see that x equal to 2 is basically within the 5 by 2 limit, right? So therefore it will have two solutions from this case, right? So for this particular case, it will have two solutions, right? Now similarly for the next case, you will try to find it out. That is, for the second case, when x is greater than 5 by 2, and then it is basically x square plus 3x plus 2 is equal to x minus 3 mod of it, right? Then this particular case will be like this, 3 over here, and then we try to find out the curve over here. But this is for the case when your x is greater than 5 by 2, right? So if x is greater than 5 by 2, we see that this particular curve, which I'm trying to draw it in the yellow color. So this particular curve, which I'm trying to draw in the yellow color, right? This particular curve with greater than 5 by 2, this particular curve is not intersecting this particular parabola. This particular parabola is not intersected after 5 by 2. So from here, we'll have no solution. Right? So ultimately, for this particular expression, we are going to have two number of real solution. Right? Which is very obvious from looking the graph of this particular problem, right? So just simply by trying to draw the graph, you can always try to find out this particular problem. Okay, so from here you will see that only two real solutions will exist. That is, option number A is going to be the correct answer for this particular question. I hope this is clear to all of you. Please let me know. If this is not clear. All right. I hope this part is clear to all of you. Right. So for solving this type of problem, it is always advisable to make use of graph, because if you do graphically the solving the question, it is very simple in order to get to the solutions also. Okay, because ultimately in this question we are going to find out the number of real solution, not the exact real solution itself, right? So whenever you have to find out the number of real solution, it is always advisable to draw the graph and find the number of intersection of the two curves. So once we get the number of intersection two curves, that will represent the number of real solution itself. I hope this is clear to all of you, right? So with this, let's move to the next problem. And next problem we have with us is basically we need to find the product of all the rational roots of this particular equation, right? So let us try to understand what this question is going to talk about, right? So this is a question really interesting, is that if you try to see at the question, it is said that x square minus 9x plus of 11 whole square of it minus x minus 4 into x minus 5 is equals to 3, right? So from this, if I consider this x minus 9x as t, now why I'm considering this, you will try to understand. So I can also write this equation as x square minus 9x plus 11 whole square of it minus, now if I just take the product of these two, I'll get this as x square minus 9x plus of 20, and that is equal to 3, right? So if I see, what I can see, this x square minus 9x is common in both the expression, right? So what if I take x square minus 9x as some variable t? right? So if I just take this variable at t, then I'm going to reduce this expression as t plus 11 whole square minus t plus 20 minus of 3, which I can simplify in terms of a quadratic equation like this, that is t square plus 21t plus of 98 is equal to 0, right? So from here I'll have two roots, so I can just simply factorize it as t plus 14 multiplied with t minus or t plus 7, which is equal to 0. So from here I'll have two roots, that is t either is equal to minus of 7 or minus of 14. And what is our t? Our t is nothing but x square minus 9x. So now I have to equate this x square minus 9x to minus 7 and minus 14. So from that I'll have two more roots, right? So from the two more roots, so if I just try to do that part, so it is all about calculation, you can see. So this is one of the quadratic equation and this is the second part of the quadratic equation to get the two of the roots, right? Sorry, plus of 14 it will be is equal to 0. So from here, if you try to find the roots by the Siddharacharya formula, and that is going to be 9 plus or minus square root of 81 minus 4 times the 7 whole divided upon 2, and from this part you will have the roots as 9 plus or minus square root of 81 minus 4 into 14 whole divided by 2. So from this you will have the rational root as 9 plus minus square root of 53 divided by 2, and this you will have a 9 plus minus of 5 divided by 2, right? So ultimately the product of the roots, so from here you will see now these are the irrational roots, right? These are the irrational roots, so I have to only find out the rational roots product, right? So these are going to be the rational roots. So from this I will have one of the root as, so one of the root from here I will have it as, so one of the root is 7 and another root is 2, right? So product of the root is going to be equal to 14. So ultimately our answer to this particular problem is going to be option number D, that is 14 is my product of the roots, right? I hope this part is clear to all of you. Is this part clear or not? Yes. Hey Anshu. Okay, fine. I hope you are following the content, right? Because those things will come up later, but first of all you have to clear the JEE, right? If you don't clear the JEE, otherwise then the condition won't be varying to you, right? So in order to clear the JEE, you need to focus on this particular concept right over here. I hope this is clear, right? All right. So let us proceed. Then this is a very similar problem. Okay, just you need to understand like how you are going to simplify or manipulate this problem, right? So instead of solving the biquadratic equation, I try to simplify it in terms of another variable so that it's a quadratic in that particular variable. And once I get the quadratic in that particular variable, I am going to find the roots in the particular and then find the roots in the original variable x, right? So that instead of solving the biquadratic equation, I'm solving this in terms of a quadratic equation in a different variable, right? So this is clear to all of you. Is this clear to all of you? Please let me know if it is clear or not. Alright, so let's proceed with the next problem. So next problem is a very interesting problem which involves trigonometry to it, right? So if you just look into this problem, it is basically talking about that if alpha theta and beta theta are the distinct roots of this particular expression or the roots of the equation 2x squared into cos of theta times of x minus of 1 is equal to 0, right? Now if you recall my initial discussion, what I was talking about, that while starting the chapter I said that trigonometry is such a thing, it is like a salt that it is put in everywhere. So even in quadratic equation you're going to see trigonometry, even in secant series you're going to see trigonometry, even in concepts of complex number you're going to see trigonometry, even in matrix and determinant you're going to see trigonometry. So even in every possible scope of algebra, calculus, coordinate geometry, you're going to definitely see trigonometry. So trigonometry is some kind of that kind of salt that is put in everywhere, right? So for that it is always advisable that if possible, please start with trigonometry as a basics part. All right. So from here, we'll see that now it is said that alpha theta and beta theta are the two distinct roots. Now, if it is saying are distinct roots, then it must be the condition that is your discriminant is greater than 0. Because if discriminant is greater than 0, then only I'm going to have distinct roots, right? So discriminant should be greater than 0, right? For having distinct roots. Now, this is something that I've already discussed in the starting of the class. So distinct roots, we should have discriminant should be greater than 0, right? Then now let us try to understand how we are going to find out the minimum and the maximum value of alpha theta and beta theta, alpha theta to the power 4 and beta theta to the power 4, right? So very simple, right? So if we need to find out alpha theta to the power 4 plus beta theta to the power 4, we can simplify and write this expression as simply as alpha theta plus beta theta whole square, sorry, we should write it as alpha theta square plus beta theta square whole square of it minus of 2 times of alpha and beta square, or theta, alpha theta square and beta theta square, which I can simplify and write it as alpha theta plus beta theta whole square minus 2 times of alpha theta beta theta, now whole square of it, right? Whole square of the expression minus 2 times of alpha theta and beta theta whole square of it, right? So we know this expression, that is alpha theta plus beta theta is nothing but it is equal to minus of cos x by 2, and that is going to be the, over here is cos square theta upon 4 minus of now that is what is c by a, or the product of the root is basically 1 upon minus of 1 upon 2. So from that I will get this part as plus of 1 and whole square of it, right, minus of 2 times of this particular part is 1 upon 4, right? 2 times the product of the root is going to be square of that is going to be 1 upon 4, right? On simplifying it further, I'll have the expression as cos square theta upon 4 plus 1 whole square of it minus 1 upon 2, right? So from this particular expression, what we know that, so cos square theta will be greater than or equal to 0, but it must be less than or equal to 1, right? It must be less than or equal to 1, because we know that cos theta lies between minus 1 to 1, so cos square theta will definitely lie between 0 to 1, right? So therefore the minimum value is going to be 0 for this particular expression for any theta. Therefore the minimum value of this particular expression is obtained by putting cos theta is equal to 0, which will generate the answer as 1 upon 16 minus 1 upon 2, and that will give me the minimum value as all right. So I hope I'm doing it correct. So from here I'll get the minimum value as, so it is going to be minus of 7 by 16, right? Minus of 7 by 16, right? And our value for maximum value, so this is going to be small m or minima, and maximum is when cos theta is equal to 1, so that will extremely sorry, so this is going to be equal to 1 minus 1 by 2, right? Extremely sorry, 1 minus 1 by 2 is the minimum value, and that is going to be equal to 1 upon 2, right? 1 upon 2, and my maximum value is going to be when cos theta is equal to 1, and that will generate me 25 upon 16 minus of 1 by 2, and that will generate the answer as 17 upon 16, right? 17 upon 16. Now ultimately we have to find out the value of 16 times of capital M plus small m. That is what we have to find it out, right? So 16 times of capital M small m is going to be equal to 17 by 16 plus 1 upon 2 multiplied with 16, and that is going to give me the answer as equal to 25, because 17 plus 8 is equal to 25 divided by 16, and 16 will cancel out, right? So from here we'll get the value of this particular expression. 16 times this particular expression is going to be equal to 25. With this we will have option number C as the correct answer for this particular problem. I hope this is clear to all of you. Please let me know if this is clear or not. All right, so I hope this part is clear to all of you, right? So this is also a very similar problem. What we have to understand is that we are going to actually use the relation of the roots with the given coefficient of a given quadratic equation, right? So we already have seen that if I have a quadratic equation and x square plus bx plus c is equal to 0, and let us say the alpha and beta are the roots, so alpha plus beta is basically given as minus of b upon n, and alpha into beta is given up as c upon a, right? These are the two expressions that we have already seen as the relation of the roots with the given variables, right? This part is clear to all of you. Please let me know. Is this part clear to all of you? Right? I'm looking through your live chat. Please, you can let me know if you have any questions. Right? So with this, we are almost proceeding towards the end of the session. Okay. So now we have the most important problem that I wanted to discuss, and this is a problem based on the recursion relation. Okay. Now this type of problem has been asked many times. Okay, I'm not going to solve this question entirely. Rather, I will give you the idea on how we are going to solve this problem, right? This question has been asked many times. Okay, so if you try to understand, this is a question. So if you just try to understand the given quadratic expression or the equation as x square minus square root 2x minus root 3 is equal to 0, and alpha beta are the roots of the equation. So from this, I'll find out alpha plus beta is equal to square root of 2 and alpha into beta is equal to minus of square root of 3, right? These are the two information that I already know, right? And now it is given that expression Pn is given as alpha to the power n minus beta to the power n, right? And for n belongs to natural number, right? So therefore from here, if I find the value of p1, it is basically going to, so p0, so what is p0? We cannot find p0 because it's not a natural number. So we start with p1, right? So p1 is going to be alpha minus beta, which is nothing but square root of discriminant upon a, right? So if we try to find out the discriminant over here, the discriminant is going to be equal to, that is going to be b square minus 4ac, right? So from here we'll have 2 minus of 4 times the minus of 3, so that is going to be 2 plus 4 root 3, right? So from this it is going to be have the form like this, right? Divided by 1, right? So that is what we have as p1, right? Now if you just look at the problem, what we actually need to find out is that we need to find out p10, p11 and p12, right? So what I will do now, this is something very interesting that is called the Newton's formula. Okay, now this is called as the Newton's formula in the quadratic equation. That is, if we are having x square, so let us say x square plus bx plus c as our quadratic equation, and alpha and beta are the roots. So if alpha and beta are the roots, and let us say I have an expression s of n which is given as alpha to the power n plus or minus beta to the power n, right? Then it will definitely satisfy s of n plus 2 plus of beta. Let us put it a over here. So a times the s of n plus 2 plus b times the s of n plus 1 plus c times of s of n is equal to 0. And this is a very important relation that you must know in order to solve this particular problem, right? Now this particular relation holds true for any general quadratic equation, right? So this is called as a Newton's formula, right? So once you know this particular formula, so from here what we can say, p of n is given as alpha to the power n minus beta to the power n, right? So therefore your given quadratic equation will be given in terms of, so from here I'll have p of n plus 2 minus square root of 2 times the p of n plus 1 minus square root 3 times of p of n is equal to 0, right? Now from here I'll put the value of n is equal to 10. So if I put the value of n equal to 10, I'll get p12 is equals to square root of 2 times the p of 11 plus square root of 3 times the p of 10, right? Now this is one of the recurrence relation I will get. So from here I'll get multiple recurrence relation by putting p of 11, we will get it as square root 2 times p of 10 plus root 3 times p of 9, and similarly p of 10 I will get it as square root 2 times of p of 9 plus square root of 3 times the p of 8, right? Now this is how we are going to simplify that expression. We are going to reduce it in terms the lowest part, that is what we know, that is p of 1. So what we can do, we can always go for a recurrence relation from here, and we can try to decompose in terms of p2, because p2 is basically alpha square minus beta square, right? So we know the value of alpha square minus beta square, so we can go with this recurrence relation to find out p1 and p2. So once we get to the recurrence relation, so just using recurrence, okay, we just need to use recurrence. So it is a recursive relation that is going to use over here. So by using the recursive relations, we're going to decompose this particular problem into the simplified relation, because what we see over here, we're going to answer this particular problem in terms of p9. On the option you can see the p9 is given, so we don't need to simplify in terms of p2, we can simplify in terms of p9 and p10. And once we do that, we'll find out that the answer to this particular problem is going to become, so if you try to solve this particular problem on your own, you will get the answer as, he'll get the answer as option number A. Okay, you can always try to solve this particular problem. He'll get this particular expression coming out as 10 root 3 p9. 10 root 3 p9 is going to be the answer for this particular question. Okay, so you can try to solve this particular problem by yourself. Okay, and you'll get the particular relation. Okay, so how I solved it, I just found the value of p12 and p11 from here, and I just put it back into this expression over here, p11 and p12 expression, right? So once I get the value of p10 and P11 and P12 in terms of P10 and P9, we are going to put it back, and we see that P10 will get cancelled out, and ultimately are left out with the answer in P9. So with this, we will understand how to apply the questions of recursive relation. I hope this part is clear to all of you. Now, I would like to give one homework problem. No, Apurva, it is not option number D. It is option number A is going to be the correct answer for this particular problem. Okay. Please recheck your calculation, Apurva. Okay. You will definitely get the answer. It's very simple. Right. And with this, I will leave this particular problem as a homework problem for all of you. Okay. So please make sure to solve this particular problem and let me know in the comment section below. Right. So with this, we are almost done with discussing the questions of the top 10 important questions of the quadratic equations, right? So we have started with the quadratic equation, where we discussed about the small recap, where we discussed the important concept that you need to understand in quadratic equation, and then we moved on to discuss about the important theorems, right? And once we're done with that, we discussed all the important questions that you can definitely check up in your JEE Mains part, right? So with this, we are completing this particular session. Right. So I hope this session was clear enough to all of you. I hope this particular session I was able to make your concepts clear. And if you still have any doubt, you can definitely put that up in the comment section. Okay. I will be looking through your comments. So I hope I tried to make something valuable for your particular part. Right. So at least you got something from this particular session. Okay. So with this, let us end our session over here. So we discussed almost 10 questions, right? And the top 10 important questions for your JEE Mains, right? So this particular part is going to be really important. So make sure to revise this part before going for the actual exam. So with this, I wish you all the best, and please make sure that you make short notes and prepare the questions accordingly, right? And thank you.